Okay, so from yesterday, some of you were gone, and there was a presentation put together. Should you choose to go watch that, notice we've got some an assignment for you today and some vocab terms that are due on Friday. Okay, and with that, okay, we talked about ring structures and fused rings. What for example, is a ring structure? If you had to name what a ring structure is, what would that be? Yeah, it's in a ring. We gave three examples. Yes, well, not multiple examples, but we had mentioned hexane. Okay, so hexane means you have an alkane. It's saturated. Everything is single bonded. And how many carbons is hexane? Okay, so if all you had seen was hexane, that tells you it's just a straight chain of carbons and hydrogens, 6 carbons and about how many hydrogens? 14. 2 for each carbon and then 1 for each end, so that's where the 13th and 14th carbons come from. So, how is hexane different from cyclohexane? What does, you're going around like this, that you're close, but what does that mean? Well, yeah, it forms a ring structure. So when you say cyclopropane, what would that possibly mean? And it forms what type of structure? Well, a ring, but 3 carbons forms a what? What's a 3-sided figure? Yeah, so cyclopropane would be a triangle. Cyclo meaning ring structure. Okay, so if you have a box, square, or rectangle, you'd be referring to what? Yeah, because butane is 4 carbons. And if it's in a ring structure, you would say cyclobutane. Okay, do we see the pattern that's unfolded? The Department of Defense is located where in this country? It's in Washington, D.C., but a little more specific than Washington, D.C. The Pentagon. So that means it is a building with how many sides? So you could say the Pentagon would be a ring structure like cyclopentane. Now do we catch the pattern? Okay, so now as we go through, what did we describe? What is a substitute? Like for yesterday, what example did we give for those of you who are here? Yeah, for any teacher. So Mr. Paulson was a substitute for Mr. Williamson. So that means it's an adult, or sometimes it's a teacher, sometimes it's not, but usually you just say an adult that fills in for a faculty member or a staff member. So that's what we mean by a substitute. So it is possible to change hydrocarbons into other compounds. So the substitution here is replacing a hydrogen with, what did we use as an example yesterday? It could be chlorine, but we use fluorine. Is that what you said? Okay. All right. So when you take that hydrogen off, put a fluorine, a chlorine, or halogen on there, that is a substitution then. That's correct. This results in different physical properties, okay? This could also include double or triple bonds, okay? We don't have a whole lot of material to go through today, just this slide of information, the last one, and this. We want to save the alcohols and acids for later. So at this level, we want to include this. This may include double or triple bonds because it totally changes the chemical makeup of that compound. How many of you have received the tetanus shot? Of course, the flu shot, perhaps last fall or spring, whenever your last shot was administered. The person giving that will sterilize where they're going to give you a shot by rubbing a cloth. Well, that's open up a packet that has cloth inside, and that cloth is saturated with what? With an alcohol. It's isopropyl alcohol, probably. And when they take that cloth and put it on your skin to sterilize that area, more often than not, it feels what? It feels cold. That is a physical property of alcohols. It makes compounds cold or cooler. Okay, that's why it feels cold on your skin. We're not going to get into this too much, but alcohols for all this because, okay, because the chemical property in them is changed because you put an OH group on there instead of just a hydrogen. So I think this is correct. Let's say if you had a squirt bottle with, if you put half water in there and put some rubbing alcohol for the other half, and rather than scraping your windshield, or if you have a remote start, you can click that. Of course, your defroster has to run for, does this sound familiar to anybody? Or you have to go start your vehicle if you don't want to scrape it, and you let it run for 5 minutes, maybe 10 minutes? Does this sound familiar to anybody? So you're nodding your head yes. Isn't that annoying? So you've done that before, and it works pretty well. Would you recommend that to anybody? It's their choice. But they could say they don't know what they're talking about. Well, I don't think you can make that up. Or did you? No, because one of the physical and chemical properties of alcohol is it lowers the freezing point. So when it does that, it's not melting the ice, it's just lowering that freezing point. Just for the same reason, okay, when the, you could say sanders or snow plows, of course, they can't go very fast, because sometimes you might get stuck behind a snow plow and you're thinking, my gosh, why are they only going 20 or 25 miles an hour? Well, probably for a couple of reasons. Well, that's why if you have any, in my opinion, if you have any, not buckling on the road, but when you have a, probably a 7-ton, 12-ton truck coming across with a blade going about 30 or 40 miles an hour, and here's your road, and part of that sticking up just a little bit, and that plow comes by and hits that, what's that going to do to the road? It's absolutely going to destroy it. But there's another reason. Why are they not going very fast? You see something trickling out the back. Yeah, it's a type of compound. If you go too fast, it's not going to spread like it should. And it's annoying, I know. But that's why you can only have them trucks going so fast. We will get into the properties of, it says, other organic families and derivatives, okay? That's not the first time that we've seen the term derivative, and either tomorrow or that of Friday we'll also be talking about alcohols and acids. So probably another paper will be assigned next week, probably a problem quiz next week. Okay, we're going to get an exam in for this chapter before the end of the semester, because just keep in mind we're winding down pretty quick. I would venture to think Okay, after this week, there's what, 2 days left in April. And then Wednesday is May 1st, correct? Okay, so May 1st, 2nd, and then 3rd, and then, what would that be? 6th, 7th, 8th, 9th, 10th, okay, 11, 12, 13, 14, 15. Now this is just approximate, so 15. We're about at 20 days of school left, or under. You would agree? Okay, so we're winding down fairly quickly. Okay, so we're done with this. We're going to work through some examples because some of you may not be totally comfortable with this. We'll catch up with the lecturing part next time.